At exactly 1:38 p.m. at Sardar Vallabhbhai Patel International Airport, an Air India flight began its takeoff roll down runway 23. It was packed with passengers, but more critically, the aircraft carried the maximum fuel load required to complete a long-haul journey to London. The initial sequence was by the book. The heavy jet cleared the tarmac, retracted its gear, and successfully climbed to exactly 625 feet. But right at that 625-foot mark, the routine sequence broke. The pilots urgently keyed their radios to air traffic control and broadcasted a Mayday call. The transmission of a Mayday signal represents the absolute highest level of radio distress, indicating an immediate and catastrophic threat to the lives of everyone on board. The threat extended far beyond the fuselage. A heavy commercial airliner, full of combustible liquid, was failing directly above a dense Indian urban center. Within seconds, a regulated international departure had transformed into an uncontrolled airborne explosive device, placing thousands of civilians on the ground in the direct line of fire. This altitude chart maps the disaster's telemetry. Instead of climbing, the aircraft plummets at 475 feet per minute. Force factors show the severity. For a heavy airliner barely establishing lift, this steep descent allows gravity to overpower the wings. Physical recovery was mathematically impossible. Simultaneously, the screens in the control tower went dark. Air traffic control lost all radio and radar contact with the falling plane. Inside the cockpit, the crew was isolated. Cut off from ground support, they fought a terminal mechanical failure and an unforgiving altitude entirely alone. The combination of severe downward acceleration and total communication failure meant a crash was a rapidly approaching mathematical certainty. Because of how rapidly it lost altitude, the crippled aircraft was physically unable to clear the immediate perimeter of the airport boundaries. Its trajectory pointed straight into Magani Nabar, a densely packed residential zone where homes and narrow streets are built shoulder to shoulder. The exact point of intersection was the airspace directly above a medical college hostel, a building currently occupied by 50 to 60 intern doctors. And then there was the compounding variable, the thousands of gallons of aviation fuel sitting in the wings and belly. Upon hitting the ground, the kinetic energy of the collision triggered a massive chemical detonation of the aircraft's fuel load. The specific geographic vulnerability of the crowded hostel, combined with that maximum fuel payload, created a worst-case scenario. The resulting inferno proved deadlier than the physical impact of the plane itself. The human toll was devastating. Passengers inside the fuselage and unsuspecting civilians on the ground perished quickly as the fuel fire consumed the entire area. Almost immediately, the standard public relations cycle began, with authorities stepping up to microphones to issue generic statements of sorrow and condolence. But we need to look past the routine messaging. Formal apologies often serve as a smokescreen, absorbing public anger while shielding the institutions from any real systemic scrutiny. We are left with a missing piece of the timeline. At exactly 625 feet, a specific, catastrophic failure brought down a modern airliner, and the public still doesn't know what actually broke. The public must apply relentless pressure to force a transparent investigation. We need concrete answers about exactly what failed and who bears legal responsibility for this disaster.